So if we have that, then let's start to do the formulation. We have the expected profit idea in mind because everything is uncertain now. There's no way for us to optimize profit. What we may do for the best is to maximize our expected profit. So the key is still we need to somehow formulate our value to go function. We need to find that Bellman equation or optimality equation so that we know from this period how to transfer to next period. So in this particular example, we still have this Vt of y, which is the expected profit in days t minus 1 up to 1. Note that previously, in the previous example, your V is the total cost. But in this problem, we define V as the expected profit, okay? And again, this is value to go. So it's starting from period T up to period 0. We are asking, starting from here, starting from period T, if we have Y units on hand, then to the end of the world, how much we may earn in expectation. Okay, so in that case, it is not very surprising that your VT again consists of two parts. You have Y at the beginning, and then you make some decision to replenish to QT, and then this QT is going to face some random demand for this period. That's going to create some expected profit for the first period. And then we also have the expected profit starting from the next day. That's something we don't need to worry because Vt minus 1 of y should already be calculated from backward induction. Okay, so let's focus more about this 1 day expected profit function. Initially, we have y units on hand, right? And after ordering, we get QT units on hand. So that's something we have. If we have QT units on hand, but we subject to a random demand D, then D may be any different values. If the realization of capital D is X, that means turns out the number of customers is small x. Then we know if X is less than or equal to QT, your amount inventory on hand, we're going to sell X units because you have 10 units, for example, your QT is 10, but only 5% comes. You're going to sell 5 units, right? And then the amount you may earn is XP. On the contrary, if the number of consumers are too many and it's more than the amount you have, then you only have Q units on hand, you're going to sell QP as your sales revenue. In any case, as long as you make an order, it's going to pay you QT minus Y times C, because QT is your order up to, Y is your current level. So QT minus Y is your order quantity, times C, that gives you your ordering cost. So combining all the things, our expected profit in period T can be calculated in this way. This is, first, we have expected revenue. Second, we have cost. Cost is certain. As long as you know how many to order, that's going to create some cost for you, okay? And this part is something we mentioned here. But we are willing to order something because that may help us increase our expected sales and expected profit, expected revenue, okay? So here, we actually have no idea how many units will be sold, how many units will be the demand. It may go from 0, 1, 2, 3, 4 up to N. Everything is possible. So basically, we need to make a calculation for the expected profit now, or the expected number of sales. If our realization is less than or equal to QT, then the total thing that we may sell is X units. When your demand is less than or your inventory, you sell whatever you have as demand. Each X has a different probability to realize. So this is the first part of our expectation. The second part is that your demand may also be greater than QT, greater than your inventory amount. Then whatever you have, you're going to sell all of them. And again, different X have different probability to realize. Then that's again some expectation thing you need to handle it. So here, this is the expected sales. So I hope if you are watching this video, I hope you are familiar enough with the expectation thing, with the probability thing. If you don't, I'm sorry, this is not a course to teach you probability. So maybe you want to take a look at your probability course or some other related materials. But here, this is exactly your expected sales. Okay? So with all of this, now we are ready to formulate our value to go function. Let's take a look. For any period t that is greater than 1, we are given y as our initial inventory amount. We somehow need to decide an order up to amount, so it's going to be at least y. We have no way to make it smaller, but if we want, you may make it bigger. Once you do it, you get to QT. That QT and that y is going to determine your one-day expected profit, u of QT and y, as something we have in the previous slides. And once you do that, you know you're going to leave something for tomorrow. You have QT, so let me do it again. You have QT after you do the ordering, but there will be random demand. So that random demand is going to be deducted from your initial inventory. If that number is positive, then it's something you have for the future. If that thing is 0 or negative, then you have unmet demand. They go away. So at the end of this period, you have nothing. Your next period initial inventory will become 0. So this is an expectation function. So maybe we want to split the whole thing into here. Again, your X can be anything. Your demand may go from 0 to capital N. If your demand is less than QT, you are going to get something at the end. You will still have some inventory for tomorrow to use. Or if your demand is so high, then tomorrow you have nothing left. You start with 0. Okay? And again, this is expectation, so we have the probability for X to do some kind of weighted average to the possible values you have. So once we have all the formulation here, we again see the clear relationship between the previous, the future periods and this periods. I'm going to decide QT. That's going to have some impact on my today expected revenue or expected profit. But also it's going to have some impact on the amount I may leave for tomorrow. If today I order more, probably I'm going to earn more, but that also have some impact on tomorrow. That's something we need to have for dynamic program. Okay, so once we make our optimal decision here, then we are able to define VT based on VT minus 1, VT minus 1. Okay, so that's our formulation. And with our formulation, if we have numbers, if we have the value of parameters, we will be able to solve our problem.